So I actually went backwards a little bit with the factoring. Typically, most teachers start with this type, with the A, or the leading coefficient of my standard form is a 1. I went backwards. Okay, so this is what we've been doing. Okay, we are undistributing a set of factors. So when we distribute, you're multiplying, right? We get x squared plus 5x plus 1x plus 5, and then we combine our like terms. And factoring goes the opposite. So distribution is some form of multiplication. Factoring is some form of division. So when your leading coefficient is a 1, the easiest way to factor is you must find two integers, so these are whole numbers, that multiply to C and add to B. Okay, so again, take the GCF out first. It's always check for GCF. But if your leading coefficient is a 1, then you go right to the C, find factor pairs of 12 that add to be 7. Okay, so the factor pairs of 12 that add to be 7 are 3 and 4. So our factors are x plus 3 and x plus 4. Okay, my plus 3 because it's positive and plus 4 because it's positive. So again, these are all positive here. So I just have to worry about what multiplies to C and adds to be B. In this case, what multiplies to be 20 but adds to be 9, that's 5 and 4. N plus 5, N plus 4. And I can do this right away because my leading coefficient is a 1. If it's not a 1, we check for GCF. If there's no GCF, we factor like we did over here. Okay, we've got w squared plus 9w plus 18. Factors of 18 that add to be 9 are 6 and 3. So w plus 6, w plus 3. Okay, y squared plus 2y plus 1. Factors of 1 that add to be 2. 1 does have a pair of factors. It's just 1 and 1. Well, does 1 and 1 add to be 2? Yes. So my factor pairs, y plus 1, y plus 1, written as y plus 1 squared. Example 4 has a leading coefficient that's not a 1. It's a 4 here. So you check to see if it's a GCF. In this case, it is. Okay, ignore the GCF, and we're going to look at the 2. My leading coefficient is now a 1, so factors of 2 that add to be 3. 2 does have a pair of factors, it's just 1 and 2. So it's 1 and 2 that add to be 3. K plus 1, K plus 2. And don't forget, I'm gonna keep having you write this to factor a quadratic trinomial in the form x squared plus bx plus c, where the leading coefficient is a 1. Find two integers that multiply to c and add to b. Okay, so in this case, we have a positive b and negative c. And we learned over here that if you have a positive b and a negative c, it's the little factor that's negative. Basically, the positive has to outweigh the negative. So factors of negative 18 that add to be positive 3. Okay, remember, 18 has these factors, 1 and 18, 2 and 9, 3 and 6. We're supposed to make the little factor negative, and it's negative 3 and positive 6 that add to be 3. So n minus 3, n plus 6. Okay, I need factors of negative 8 that adds to be 2. Negative 8 has factor pairs of 1 and 8, and 2 and 4, with the little factor being negative. Negative 2 and 4 add to be 2. X minus 2, x plus 4. Okay, y squared plus y minus 6, no GCF or anything. Negative 6, 1 and 6, 2 and 3, and I need a factor pair that adds to be, well, hello. That adds to be 1, sorry about that. And our little factor is negative. That's going to be negative 2 and 3. So y minus 2, y plus 3. Example 4 has a leading coefficient that's a 2 right now. We use it to see if it's a GCF. In this case, it is. Take a 2 out. Factor pairs of negative 16 that add to be 6. With the little factor being negative, it's going to be negative 2 and 8. So k minus 2, k plus 8. Bring down your GCF. Okay, factoring that quadratic polynomial, a trinomial with the leading coefficient 1, what multiplies to c and adds to b. So this time everything is negative. B and c are negative. Okay, and we've done that. Oops, wrong way. B and c are both negative. It's the big factor that's negative. The negative has to outweigh the positive here. Okay, so I've got factor pairs of negative 3 that have to add to be negative 2. Okay, negative 3 only has one pair of factors. It's 1 and 3. And the big factor is negative. So that means that's my only factor pair. Do they add together to be negative 2? Yep. So n plus 1 and minus 3. Okay, factor pairs of negative 30 that add to be 7. So 1 and 30, 2 and 15, 3 and 10. Now I'm going to stop there because I know if I make the big factor negative, that's where my negative 7 is. So x plus 3, x minus 10. Okay, negative 64, that adds to be 12. Negative 12, excuse me. So 1 and 64, 2 and 32, 4 and 16. There it is. If I make the big factor negative, 4, negative 16. Leading coefficient on 4 is not a 1, it's a 2. So I need to see if it's a GCF. It is here. Factor pairs of negative 12 that adds to be negative 4. 1 and 12, 2 and 6. There's another one, but that's the one I need. 2 and negative 6. K plus 2. K minus 6. Bring down your GCF. And the last type, again, negative b and positive c. Multiplies to c. And adds to b. Okay, so to get a positive c but a negative b, both factors negative. So factors of 24 that add to be negative 11 are negative 3 and negative 8. So x minus 3, x minus 8. When I multiply negative 3 and negative 8, I get positive 24. When I add negative 3 and negative 8, I get negative 11. Factors of positive 49 that add to be negative 14 are negative 7 and negative 7. Needs to be written as negative minus 7 squared. Factors of 72 that add to be negative 17, that's negative 8 and negative 9. Okay, if you know your factor pairs, you don't have to list them like I've been doing. GCF first. This one has a leading coefficient of 3. See if it's a GCF, and it is. Factors of 4 that add to be negative 5 are negative 1 and negative 4. And bring down your GCF. This type of factoring is vital. You have to be able to see factor pairs. Okay? Now, it does take a little bit of practice. You get used to it. And if you have to list, you list it. It's no big deal. I can list factor pairs of 24. It's 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I literally just start with 1 and I work my way down. Okay, you can do that if you need to. Nobody's stopping you.